Yes, ma'am. All right. Okay, so I think we'll go ahead and get started. Good morning, everyone. We just want to thank you for joining today. Just a quick introduction. My name is Morgan Napier. I'm one of the business development reps here on the West Coast for ALS Global. Juliana will be providing you all with all of the information you will need to know about SPF testing today. So just a quick overview of the agenda. We'll discuss what causes a sunburn and the different radiations emitted by the sun and the effects of the radiation itself. We'll move along to discussing sunscreens and the different types. And the final topic will cover claims for sunscreens, and we'll share a few examples. We'll go ahead and finish off the webinar with a Q&A. So if you have any questions, we ask that you please add them to the Q&A section at the bottom of your Zoom screen, and we'll address them one by one at the end of the webinar. Just a little overview of ALS. We are a global leader in providing laboratory testing, inspection, certification, and verification solutions. We also run HRPT on a weekly basis, as well as clinical testing for efficacy, and our headquarters is in Houston, Texas. Now to introduce Juliana. Juliana has her bachelor's in biological sciences and a postgraduate degree in business management and strategy from the University of Campinas. She has over 13 years of experience with sun care clinical studies, and she is currently serving as our laboratory manager at ALS, overseeing technical photo protections and the hair trust lab. A few impressive achievements that she has led key initiatives, including establishing an ISO 17025 certified calibration laboratory, which is the first one certified to calibrate sun care equipment in Brazil, and implementing photo protection methods internationally. I will go ahead and let Juliana get started with her presentation. And as I mentioned, if you all have any questions, please add them to the Q&A portion and we will address them at the end.
Thank you, Morgan. Hello, everyone. It's a pleasure to have you all here. Before starting with the claims, I would like just to remind everyone about UV radiation and why we need to protect our skin against UV. So it is well known that the sun is a light source and it emits radiation. We know that 50% of the radiation that comes from the sun is visible light, 45% is infrared, and only 5% is UV or ultraviolet. And we also know that ultraviolet is divided into 3 regions, which is UVC, UVB, and UVA. And from this 5% here, in the surface of Earth, we do not have any UVC reaching the surface because all of it is blocked by the ozone layer. So we have the majority is UVA, which is 95%, and then 5% is UVB. And we know ultraviolet radiation has some beneficial effects in our skin. For example, we need UV to produce vitamin D. It is also used for some treatments of some diseases, and also the sun helps us with our endorphin levels to make us feel a little happy. So in small doses, sun radiation is good, but usually we need to take care about the damages that it can cause in our skin too. So here I presented a summary with the damages that the UV radiation can cause in our skin. So for example, UVB is the one that reaches into the epidermis of our skin, and it can cause sunburn. So it is the main responsible for sunburn, because sunburn is inflammation of the skin. So it's the redness that we see when we get burned, when we get sunburned. So sunburn is caused by UVB, also DNA damage, immunosuppression, and also is related to cancer, and also the tan. The tan that we see in our skin is usually a natural reaction of our skin to protect itself from future exposures. So melanin is a natural a molecule that absorbs UV radiation. So it's like a natural protection of our skin for future exposures. So every time we expose ourselves to UV, UVB, UVA, or visible light, it will always be a pigmentation of the skin, because it's a way of the skin protecting itself against future exposure. UVA gets deeper in our skin, so it's able to reach the dermis, and it also causes tanning, photoaging, and cancer. Visible light is, there are some studies coming up now saying that it's related to the pigmentation of the skin. It also reaches the dermis. And infrared only causes us the sensation of heat. Infrared usually agitates our molecules, so it will cause us to feel that warm feeling of the sun. So that's the infrared that is causing us to feel the heat from the sun. So to protect our skin against UV, we need to use sunscreens, right? So sunscreens are usually cosmetics. Also, some places consider as cosmetics and others consider as drugs. So USA, for example, is well known that their sunscreens are drugs. It's not cosmetics, but in majority of places, sunscreens are considered as cosmetics, and they are both for skin or lips, and they have the exclusive or main purpose to protect the skin against UVB or UVA and UVA radiation, actually. In some places, we have what we call multifunctional products, or secondary sunscreen, as it's called in Australia, for example. They are products that their exclusive, their main function is not to protect the skin, but the protection against UVA and UVB is an additional benefit. So those products, in some places, they have different requirements. For example, lipstick with sunscreen, it's just a lipstick. The main function is not to protect the skin, but it is to maybe color your lips. So the UV protection is only an additional benefit. So in some places it has different requirements, and it is considered as multifunctional products. In other places, such as USA, it's still a drug, so the same requirements apply. Now, let's go into the claims, the main claims for sunscreen. So the first one and most important one is the SPF itself. So SPF stands for sun protection factor, and this study, when we are determining the SPF, the end point of the study is the sunburn, is the erythema. So we are evaluating the protection against sunburn, which the technical term is erythema. And we know that the sunburn is caused by UVB radiation only. So when we are talking about SPF, we are talking about protection against UVB radiation. This number here is mandatory, so all sunscreens, they have they need to have the SPF determined, and it goes to the label in very wide words there. So it also, when we are evaluating the SPF, we are evaluating the static SPF, which means that the SPF is applied on dry skin. So if you hear the word static SPF, you know that it is the regular SPF that goes to the label, and it is applied on dry skin. It can vary from 2 to 99. Of course, if you have a sunscreen, even in places that they have this differentiation between sunscreen and multifunctional products, a sunscreen, they have to have at least SPF 6. So 2, it's only for places that accept multifunctional products, and then you can have SPF 2, 4. But if it's a sunscreen, then you need to have at least SPF 6, and it can go up until 99 depending on the place. But in some places, like Europe, for example, you cannot label your product with higher numbers than SPF 50 plus. And even 50 plus, depending on the country, the region that you will register your product to use this 50 plus, will depend on the region, on the regulatory requirements of that specific region. So for example, in Europe, you can use SPF 50 plus if the average in vivo SPF that you will obtain for your product is higher than 60. Then you can use 50 plus. On the other hand, for Japan, for example, it's not the average that you use to determine if you can use 50 plus or not. It's the lower limit of the confidence interval. So if you have an average for of 55, for example, but your lower limit is 49, then you cannot use 50 plus. You will have to use 50, for example. You can only use 50 plus in Japan if your lower limit of the confidence interval is higher than 51. So how to test it? How to substantiate the SPF? Right now, we have two methodologies that are very similar, but they are not the same. Like they have some differences that are ISO 24444, and FDA monograph. They are both in vivo methodologies. We'll be having very soon two new methods, alternative methods. One is completely in vitro method, and the other one is a hybrid method, because we have a hybrid method using both in vitro and in vivo measurements. By the end of the year, probably we will have this publication in ISO website, but right now we still have only these two monographs standards, and they are both in vivo methodologies. So when you want to determine the SPF of your product, you need to use these two options here, only one option, of course, or you will have to check the requirements of the country that you market your product, because, for example, FDA is accepted in USA. USA only accepts FDA. So and Europe, on the other hand, only accepts ISO. So if you will sell your product in Europe, and the same product will be sold in USA, you will have to do both methods, because these Europe and USA, they accept different methodologies. So you have to comply with both of them. You have to do both of them. There are some adaptations of this static SPF, that is immediate protection. This claim here is very common here in South America. In Brazil, I can say that it's very, very common to use immediate protection. This is an adaptation of ISO. Instead, the standard procedure for static SPF, we apply the product and then we wait 15 to 30 minutes to expose the test site to UV radiation. So to claim immediate protection, it means that the product needs to be exposed immediately after we applied. So we do an adaptation and we just decrease this drying period. Instead of using at least 15 minutes, we just decrease it to 3 minutes. And we immediately expose the test site to UV radiation. In 3 minutes, it's only the time needed to position the solar simulator in the subject's back when we are testing the product. Of course, this is an adaptation. So some places, especially if the sunscreen is considered as drugs, it's not allowed. So for example, for USA, it's not allowed because it doesn't say in the monograph, and you want to stick to what says in the monograph. Another adaptation possible is wet skin, because as I said, static SPF, the product is applied on dry skin. If you want to test if your product works when applying to wet skin, you need to do another test, which is the SPF on wet skin. It's also an adaptation. The only difference is that instead of applying in the dry skin, we ask the subject to go into a bathtub for 5 minutes just to wet the skin, and then we apply the product on wet skin. That's the only difference. And also, this is not allowed in places that sunscreens are considered as drugs or they are highly regulated. So other places, like this is a very common claim here in Brazil also. SPF is measuring the protection against UVB. Now we have to talk about UVA, because UVA is also dangerous for our skin. So to protect against UVA, there is another factor that is the UVA protection factor, or UVA-PF. So this factor here is analyzing the protection against UVA. Usually, in the majority of places, the requirement for UVA protection is that the UVA-PF needs to be at least 1/3 of the SPF. And then you can use this symbol here, UVA, with a circle around it. So usually to use the symbol, you just need to comply with the UVA requirements of the country. So if the regulatory agency asks to have a UVA-PF of at least 1/3 and critical wavelength at least of 370 nanometers, and you comply with that, you can use this symbol. Otherwise, you cannot. So how to substantiate the UVA protection factor? Now there are two options available. One is in vitro and the other one is in vivo. The in vitro is ISO 24443. And in vivo 24442. You can use both of them. They are both accepted, both validated, so you can use any you want. But ISO 2443 is more usually used, is more common, because we have one method that determines both UVA-PF and the critical wavelength, and it is in vitro, it's faster, it's cheaper, it's not involving any subject. So usually people prefer testing with ISO 24443. And if, of course, there are some specific products, for example, with very high SPF or with mineral filters that sometimes can have lower results in the in vitro method, then you can try using the in vivo methodology. And in some places like Japan or Korea, they do not accept in vitro measurements, so you need to do the ISO 24442 study in vivo to determine the UVA-PF. And also, just a reminder that USA does not require the determination of UVA-PF at all. So it only requires the critical wavelength, so you don't need to calculate the UVA-PF for your product if you're going to market only in the USA. PPD is a very common word too. It stands for persistent pigment darkening, and it's just a different word, another word for UVA-PF, because in the UVA-PF study, we are actually evaluating the persistent pigment darkening of the skin after it's exposed to UV radiation. So it's the same study. So if you want to use PPD, whatever number it is, you just need to determine the UVA-PF using any of these standards, and then you have your PPG. It's the same thing. It's just the first word that they started using for UV protection, and now they have the UVA-PF, but it's the same thing. So it means the same thing. It's not a different test. PA, this classification for UVA protection is just another classification too. So you have to do the UVA-PF determination according to ISO 24442 or 43, in vitro or in vivo. And depending on the result you have for your product, depending on the UVA-PF, the average UVA-PF, you can have your category of protection here. So if you have a UVA-PF from 2 to 4, you can use 1, 4 to 8, you can use 2 crosses, 8 to 16, 3 crosses, and higher than 16, 4 crosses. So this is not required classification for sunscreens unless you are in Japan or South Korea. So there you have to use this classification. So you can just use this classification only if you need to, like for marketing reasons, you want to put that in your label, and then you just need to do your test according to this and ask for the CRO to include this classification in your report. No additional study is required to have this classification. It's just a classification based on the Japanese standard. Boot star rating. It's another symbol that we usually see, especially in the UK. You can see something like this in the bottle. So it's just another classification according to the ratio that the product has, the UVA and UVB ratio. It's an in vitro method. This one, on the other hand, it's necessary to test using the boot star rating method because it's an in vitro study. We need to apply the product in a test plate and measure the absorbance of the product both in the UVB and UVA region, and then we expose the test site, measure the test plate, and then we measure the absorbance again. And this ratio, both before irradiation and after irradiation here, will determine the number of stars you can use in your classification. Again, this is not a requirement. You need to test only if for marketing reasons you want to use this classification, then you have to test it. Otherwise, you don't need to do it. You just need to comply with the requirements of the countries that usually is SPF, UVA-PF, and critical wavelength, or water resistance that we are talking about in a few minutes. Spectrum protection. Broad spectrum protection is another way of evaluating the UVA protection and how broad is your protection, is the protection of the product. So products need to protect against both UVB and UVA radiation and also against longer UVA radiations. So UVA goes from 320 nanometers to 400 nanometers. So we need to make sure that our product is protecting against the longer UVA radiation that are those next to 400. So from 370 to 400 nanometers. So one way of making sure of that is calculating the critical wavelength, which is a requirement for most places, except for Japan, because it requires only the UVA protection. But in all other regions, the critical wavelength is a requirement, and the minimum requirement is that the critical wavelength needs to be at least 370 nanometers. How to calculate that? You need to do our ISO 24443, the same one that is used to determine the UVA-PF, or you can use the FDA monograph. The FDA monograph has a part describing the in vivo methodology to calculate the SPF. It also has the water resistance, and it also has the calculation for critical wavelength. So it has those three parts in the monograph. So you can use either one of these to calculate your critical wavelength. You just want to make sure that you're using the right one according to the country, because, for example, in the USA, they just accept the FDA monograph. So you need to do FDA. In Europe, they accept ISO, so you have to do ISO. In Brazil, for example, they accept both. So either one of them you can use. So you have to check the requirements of the country that you will market your product to make sure you are using the right methodology. Water resistance. Water resistance is also evaluating the protection against UVB because we are talking about SPF. However, it evaluates the SPF under a stressful situation, such as water immersion. So there are basically two claims that are water resistant and very water resistant. When to use them, it depends on what you want to put in your label. If you want to say that your product is water resistant, your product needs to resist to a 40 minutes immersion in water. And if you want to say very water resistant, your product needs to resist up to 80 minutes of water immersion. Right now, we have these methodologies available to use. We have two ISO, one COLIPA and one FDA. Colipa and the FDA monograph are the older ones, let's say that. ISO are, these two are more recent. The tendency is that ISO will replace Colipa, but FDA, we still need the FDA to adapt and see if they're going to accept ISO or not. So we're still testing using FDA. So this first one, ISO 16217, describes the method to calculate the SPF only after immersion. So there are some places that does not require this comparison between static SPF and after immersion, and does not require a calculation of percentage of resistance. So they are more strict. Some places such as USA and Australia. Australia is accepting these ISO. USA is accepting only monograph, but the rationale is the same. Like if you want to say your product is water resistant, the SPF that you will put in your label is the one that you will obtain after the immersion. So you don't even need to calculate the static SPF if you don't want to, because the one that will go to the label is the one that is obtained after the immersion. That's why we have a separate ISO, just to calculate the SPF after immersion, and we have another one to calculate the percentage of resistance, because in other regions such as Europe or here in Brazil, we have a percentage, like we accept a percentage of loss of efficiency for sunscreens. For example, if a product is SPF 50 and it is water resistance, it means that the static SPF is at least 50, but after immersion, it can lose up to 50%. So we can have an average SPF of 25, and that will be okay, and then we can say that the product is water resistant. So in some places, we need to calculate the percentage of resistance. So when we need that, we can use both ISO or Colipa. That will be comparing the SPF after immersion with the SPF after immersion with the SPF before immersion, that is the static SPF. And the FDA monograph, as I said, they don't require percentage of resistance. They do not accept it. So we just need to determine the SPF after immersion, and that's the one you will use in your label. Of course, if you want to test the static SPF anyway to see how far your product can go in terms of SPF, you can test it, but the one that will be used if you want to claim your product as water resistance is the one after immersion. Another important point is that I mentioned only 40 and 80 minutes because Colipa and the FDA monograph only mentions those two options, but ISO here, they mention the procedure to increase the period, so we can use more time if you want to claim a different time, not only 40 or 80 minutes or I don't know, 6 hours. You can do that. We just need to increase the period of water immersion. But again, the methodology describes it, but you still need to make sure that the regulatory agency accepts it. Some variations of water resistance. When we are testing the regular water resistance test, we use potable water. So it's just regular water. But when you want to say your product resists to chlorinated water or salty water, you need a different test. Of course, in the water resistance test, we are using potable water, which is in theory the most stressful for the product. So if your product resists to potable water, in salty water or chlorinated water, it will probably have better results. But anyway, if you want to put this in your label, some regulatory agencies request this, that the sunscreen is also tested in chlorinated water and salty water. So we just make an adaptation of the method, and instead of using potable water, we just add chlorine or add salt to the water. So how to substantiate it? It's the same methodologies. I just did not mention here the FDA monograph because, as I said, FDA will probably not accept it. So I just mentioned the options here, ISO or COLIPA, to be adapted. Sweat resistance. Sweat resistance, any product that passes the water resistance test can be claimed as sweat resistant as well. As I said, water, a period inside water is very stressful for the product. So it's more stressful for the product to be immersed in water than submitted to a sweat period. So usually agencies accept water resistance tests to claim sweat resistant. So you just need to choose any of these methodologies for water resistance and ask for the CRO to include in the report the word sweat resistance because it's both sweat and water resistance. Anyway, there's an option like if you want to test if your product resists to sweat, to real sweat, we can do that. We can test against sweat, asking for the subject to go into a sauna instead of going into a bathtub. So usually we use 2 hours of a sauna period, and then we calculate a percentage of resistance just as well as the water immersion procedure. It's just an adaptation. We use the same methodology. We just change, instead of water immersion, we ask the subject to enter into a sauna for a period of sweating. Now, visible light protection, blue light protection, and high energy visible light protection. These three, we are talking about visible light. Visible light is the one that we can see with our eyes as colors. So visible light means protection against all colors, all radiation inside 400 and to 800 nanometers. That includes from blue light until red light. When you ask for this type of test, visible light, you cannot differentiate how your product is behaving by color, but you have like a total amount of protection for the entire visible light range. Protection against blue light, on the other hand, we will measure only the blue light range, that is from 400 nanometers to 400 to 500 nanometers. Of course, if you're testing against visible light, we are measuring the entire range. So if you want to know how your product is behaving per color, of course, we can calculate that. But if you ask for only for a blue light protection, then we are not measuring the entire range. So you cannot know how it is protecting against all visible light, only against blue light. And the last one, high energy visible light, is just another word to say blue light. And why do they say high energy visible light? It's because we know that there is a law in physics that the lower the wavelength, the higher the energy that the wave carries. So blue light inside the visible light, that is 400 to 800, blue light is the lowest one. So it has lower wavelengths. So it has more energy than the other colors. That's why they call high energy visible light, because it's the type of visible light that has more energy. That's why they say high energy visible light, but it's the same thing. So if you want to claim high energy visible light protection, you just need to do a blue light protection and ask for the CRO to mention high energy visible light in your report, just to make sure you don't have any questions from the regulatory agencies. These three here, as I said, it's an evaluation of visible light, so the light that we can see. So it's more common to be tested on colored products, because products that form a transparent film, it means that we cannot see the film. It means that when you apply the product, you can see below the product, you can see the skin. So if you can see the skin, if you can still see the skin below the product, it means that the visible light reached your product passes through your product, reaches the skin, and goes back to your eye. So it means that it's not protecting against blue light. So because if the product is protecting against blue light or visible light, you should be able to see the product. If it's transparent, it means that it's not protecting. So it's more common to be tested on colored products, and we usually see higher results for products that have pigments on it. How to substantiate it? You need to do an in vitro method based on spectroscopy, like spectrophotometric measurements. We just measure the absorbance or the transmittance in the visible light range or only in the blue light range. And then we can calculate how the percentage of radiation that is blocked. We cannot know if it's being blocked by absorption or reflection, but we know that it's not reaching the skin. And usually this is not very well regulated, so there's no requirement, nothing written, nothing saying the criteria that you can use to say that your product protects or not. So usually here in Brazil, for example, our regulatory agency usually accepts this kind of claim, not saying a protection factor, but only the statement protects against visible light, for example. And they accept this claim when they have, when you present a report showing that your product protects against more than, blocks more than 50% of radiation. But again, there's no criteria, so it can vary from country to country. You just need to confirm with your regulatory agency what are the requirements to use these kinds of claims. Photostability, the last one that I'll be talking about at this webinar. Photostability is also another claim that is not well regulated, so there's no criteria specified to say that your product is photostable or not. And in vitro, we use an in vitro spectrophotometric measurement technique also. So we just measure the absorbance of the product both before and after a certain dose of UV. And this dose will depend on what you want to claim. So if you want to say just photostability, it's the regular photostability, and we will use a dose proportional to the SPF of the product. If you want to say it's photostable for a certain amount of time, for example, 2 hours, 4 hours, 12 hours, we will calculate the proportional dose, meaning like 12 hours of sun exposure. Then we will calculate similar dose in our solar simulator, and we will simulate 12 hours of sun exposure in our simulator. And then we expose the product to that dose and compare to the absorbance before and after the irradiation. And we can calculate the percentage of photostability. But again, there's no criteria. Usually here, if the client has no criteria determined, we use 80% because it seems like a reasonable percentage of decrease. But again, there's no criteria. The company, the manufacturer can have their own criteria as long as they have it well documented and they can explain the rationale to the regulatory agencies, then they can use their criteria. It's not very well regulated. To finish our webinar, there's just an example here of any label. We can see here several claims. We can see here the ones that are related to sun care, SPF 30, UVA, UVB. If you want to just say UVA, UVB like this, you just need to calculate the SPF and comply with the requirements of UVA, and then you can use these types of statements here, UVB, UVA protection. We also have some efficacy, some claims related to efficacy claim support, like whitening, protect your face and exposed areas, moisturizing. We also have the safety ones that is dermatologically tested, the sensory, non-sticky, but we also have this one here. Protects against skin darkening and premature skin aging. These types of claim is related to sun care also, because any sunscreen that has an SPF determined will help to prevent skin aging and skin darkening. So this kinds of claim here does not need a special test. You just need to use to determine the SPF and the UVA-PF protection, and then you can use these kinds of claims in your product. That's what I wanted to share with you today. Do you guys have any questions? Morgan, do you see any questions there?
Yes, there are a few. So we had someone ask, are printouts from this webinar available to viewers? If so, how do we obtain them? We will actually be posting this on our YouTube channel, as well as emailing a link to everybody that was registered for the webinar. So that is how you can share this with your colleagues. Another question. Several ingredients claim SPF boosting effects. What is the typical testing strategy to support this type of claim?
Well, SPF boosting is just you don't need a special test. You just need to calculate the SPF. These boosters, they usually help with increasing the SPF of your product. So if you have a formulation that usually you obtain SPF 30, when you use the booster, it is expected the SPF is higher. So for the consumer, it doesn't really mean anything, because the important message that the consumer sees is the SPF. So if you use the booster or not, the label that you put there is the one that you obtain in your test. The only difference is that if you are using the booster, you might have higher SPF, but what will differentiate it is that you just label with a higher SPF. So it's not a special test that you need to do. You just need to determine the SPF, and that's it.
Thank you. Another question, what tests need to be done to support claims like prevents skin cancer and photoaging?
Any sunscreen that has a high level of SPF and UVA protection, complying with the regulatory requirements, can use these kinds of statements. So as I said, in this example here, it's just the same. Any sunscreen can use that because any sunscreen helps preventing skin cancer.
Thank you. There are two more. How can the claim reef safe be substantiated?
Okay, reef safe usually refers to sunscreens that are formulated to be free from certain chemicals. Some UV filters, such as oxybenzone, there are some studies correlating the use of oxybenzone that is contributing to coral bleaching. So usually it's not an additional test that you need to do. You just need to make sure you're not using those UV filters that are related to those actions in the coral reef. So, and you can use those kinds of statements.
Perfect. And lastly, when can I use the claim very high protection?
Protection is also a type of classification, like there are low protection, medium protection, high protection, and very high protection. So no additional test is also necessary. You just need to determine your SPF, and according to the SPF that you obtain, you will have your classification. So for very high protection, it means that you need to determine your SPF, and the SPF needs to be higher than 50 plus, for example, and then you can use very high protection.
Perfect. If you have any other questions, you can drop them in the chat. Otherwise, we will go ahead and wrap up. All right. Thank you, Juliana.
Thank you. Thank you, everybody. I hope you enjoyed.